Now we're going to create a do file. Previously we have seen different ways of opening the do file editor. This time I'm going to open the do file editor by typing do edit. Now that we have the do file editor open, we're going to start do file with command clear, which clears the datasets that are in memory. Next, we're going to load the same data as in previous question. So we'll type use EC252 lab data 2 and clear. First, we're going to generate a new variable called region with some unknown values. And in Stata, if we want to specify unknown values, we can use a dot, which is called the system missing value. It is also generated by Stata when it cannot assign a specific value. So we're going to type generate region equals to dot. And next we're going to use command replace in order to change the contents of an existing variable. We're going to type replace the value of region with the value of 1 if the person lives in the north central region. Next we're going to type replace the value of region with the value of 2 if the person lives in the southern region. We'll apply the same procedure for variable west. We'll type replace the value of region with the value of 3 if the person lives in the western regions. Okay, variable east is a bit more interesting. As you may have noticed, there is no variable named east, and the reason is to avoid situation of multicollinearity. So in order to identify our base category, which is the eastern region, it must be true that for all other 3 regions, the entry must be 0. So we type replace region with the value of 4 if the variable north cent equals to 0 and the variable south equals to 0 and the variable west equals to 0. We're going to tabulate region. Next, we're going to create a label. We're going to type label, variable, region, and we're going to call label as region of residence. Next, we're going to create a value label. So the first step is to define a value label. So we type label, define, and we're going to call our value label as region label. And next we're going to instruct Stata to assign to the value of 1 a label called North Central US. And to the value of 2 assign label South. To the value of 3 assign label West. And finally, to the value of 4 assign label East. And next step is to assign this value label to a variable region. So we're going to type label values of a variable region using value label called region label. And next we're going to tabulate region again. In order to save do file, we're going to click on Save. We're going to save this file in our folder EC252 Stata lab, and we're going to call this do file, let's call it question 3. We'll click on Save. And there are two ways to run do file. First is to click on the execute icon, and the Stata executes every command written in do file one by one. And second way is to type do and the name of the do file, which is question 3. And we get the same output. Theegen command, which stands for extended generate, works just like generate command, but with extra options. So we typeegen, and we generate a new variable containing the average wage, and the option by region tells Stata to compute the average wage for each region. Now we're going to type command by sort region, summarize wage. Using sort option, first we're instructing Stata to arrange the data into ascending order based on the values of the variable region. Second, using by option, we're telling Stata to summarize wage for each region. We could also type by region, sort, summarize wage, and we get exactly the same output. In order to test whether wage is different by gender, we could use command t-test, which performs a test on the equality of means. So type t-test. Next we're going to need two variables. First is wage, which is a variable we are testing, and second is female, which is a group variable. And then we use option by to specify female as a group variable. The group variable female is binary, that is, it takes only two values, 0, 1, and these values indicate two groups that Stata will use to test the hypothesis. The output shows summary statistics for males, and also summary statistics for females as a separate group. We also see combined summary statistics on the next row, and below that we see summary statistics for the difference. So the mean difference between the two groups is 2.52, and we have standard error for that difference of 0.3. Here Stata tells us that the null hypothesis we are testing is that the difference between the two groups is equal to 0. And here the t-statistic for our test is 8.26 with 524 degrees of freedom. Below we have three choices for alternative hypothesis. In the middle we have the two-sided alternative that the difference is not equal to 0. It could be greater than 0 or less than 0. The reported p-value is less than 1%, so we reject the null hypothesis of the equality of two means. There may be times when you would be interested in doing a one-sided test. Here we have the alternative, that the difference is less than 0. And the alternative hypothesis we could consider is that the difference is greater than 0. So in this case, we would report a p-value of 0. To test whether wage is different by race, we type t-test wage. And now our group variable is non-white. And we fail to reject the null hypothesis that the wage has the same mean within the two groups defined by race. Next, we're going to test whether wage is different by marital status among women. So we'll type t-test wage if female equals 1. This instructs Stata to use only the data specified, which is women only, and by married option specifies a group variable that will define the two groups for hypothesis testing. And again, we failed to reject the null hypothesis. To create a scatter plot of wage and education, we type 2a scatter wage education, and we're gonna name the graph as graph 1, and this produces a scatter plot. Now we're going to run regression of wage on education. We're going to type regress wage education. Next, we're going to compute fitted values using command predict, and we're going to name fitted values as wage hat. Next, we're going to compute residuals. We use command predict, and we're going to call residuals as epsilon hat. And by using option residuals, we're telling Stata to compute residuals. Now we're going to draw a scatter plot of fitted values against education. We're going to type 2a scatter wage hat education, and let's call our graph as graph 2. And this produces a scatter plot. If we want a graph with connected points, we could use a plot type called connected. So we type 2a connected wage hat education, and let's call our graph as graph 2 again and replace the old one. And here we produced a graph which connects the points of wage hat and education. And if we want a graph which connects the points without marking the actual points, we could use a plot type called the line. So we type 2a line wage hat education, and let's call it graph 2 and replace the old one. We could also combine previous two graphs, graph number 1 and graph number 2. And we're going to use command lfit, which will plot linear prediction. This command is very helpful because we don't need to run regression of wage on education, then say fitted values, and then draw a scatter plot. So first we're going to draw a scatter plot of wage against education. We're going to type 2a open brackets scatter wage education, close brackets. And next we're going to place on top of that the prediction from a linear regression of wage on education. Open brackets, lfit, wage, education, close brackets, comma, name, and we're gonna name our graph as graph3 and replace. To create a new variable lwage, we're gonna type generate lwage, which is the natural logarithm of wage. Next, we're going to label our new variable. We're gonna type label variable lwage and describe it as log of wage. Now we're going to run regression of log wage on education. We're gonna type regress lwage education. Now we have a model where we use natural logarithm of wage as a dependent variable, and this model is called the log level model. Now the coefficient on education has a percentage interpretation when it is multiplied by 100. So the model tells us that the predicted wage increases by almost 8.3% for every additional year of education. The computed t-statistic is 10.94, and the log p-value suggests that the parameter estimate on education is statistically significant at the 5% level. The R-squared tells us that education explains about 18.6% of the variation in log wage. Next, we're going to save this dataset. We're going to type save, my data, lab2, and replace. Next, we're going to close the log file. We'll type log close. And that's it for lab 3. I hope you enjoyed this tutorial.